Day 162, Honors Physics, Photoelectric Effect, actually just quantum physics here. Problem number 30. Once again, we're starting in the upper right over here, using our shortcut for the energy of a photon, because we're given the wavelength of the photon. So if we plug in to this equation I have circled in blue, which is the combination of the two basic equations, the energy of the photon, let's do this in joules for picking the joule version of Planck's constant. So this will give you the energy in photons, or energy in joules, of one photon of wavelength 694 nanometers. That's one photon. So you'll need to multiply that number times the 10 to the 30th. Multiply by 10 to the 30th to get the total energy of all those photons. After you've multiplied by 10 to the 30th, multiplied this number by 10 to the 30th, you will take that answer, that's the energy output in that particular time period of 0.8 seconds. You'll take that energy, plug it in here, and that energy divided by the time gives you the power. It'll come out in watts. So that's part A. Now part B I haven't really prepared you for quite yet. There's another equation. So I'm going to go to the next page. This is something actually new, and you want to put this in your notes. Sorry about that. So let me pause and go to the next page and explain the momentum of a photon. So up here in this red circle is an equation I have not given you yet. This says that the energy of a photon is equal to its momentum times the speed of light. So the P here is lowercase p, not power. And this seems a little strange because photons have no mass, but yet they have momentum, and the units are kilograms meters per second. Energy of a photon, you want to have this in joules, equals the momentum times the speed of light, as always, 3.00 times 10 to the 8th meters per second. So in other words, if you take this equation and rearrange it, solve for P, P being the momentum of a photon is equal to the energy of the photon divided by the speed of light, the speed of those photons. So you get the energy of a single photon from the previous page. Those photons we calculated in part A, the energy of a single photon divided by the speed of light will give you the momentum of one of these single photons in this particular problem. Energy of the photon divided by the speed of light. Momentum of the photon. Then if you have a whole bunch of photons, in this case 10 to the 30th photons, so you're going to multiply by 10 to the 30th to get the total momentum of that beam, of that laser beam. And that will solve the problem for you.